The purpose of this video is to guide you through the steps you need to follow in order to format your data so that you can proceed to the next steps of the analysis. Not everything here is going to apply to every project, so just pick out the pieces that are relevant to you and your data set. So the general scheme is that we have some different data types going into different columns in Excel, and we want to use Excel because it's got the greatest ability to perform the later analysis steps that we need. So in the first column, or maybe the first couple of columns, that's where you want your predictor variable or variables to live. You will have at least one response variable that would be represented by the pink column in this example sheet. And if your project is comparing two different groups, your response values for one group will be in the pink column, and your response values for the second group would be in the yellow column. So I've made some examples here that we can work through. So let's say that my example project here focuses on the effectiveness of this new medication that's supposed to grant immortality. So I could have different hypotheses here, and each one addresses sort of a different data type. So one of these is probably going to be more applicable to what you did than the other. So one hypothesis might be about the dose of the medication. So an example hypothesis could be this: if the dose influences the effectiveness of the medication, then patients who are given a greater volume of the medication should experience greater immortality in the form of fewer deaths overall, because more medication leads to greater capacity to fix underlying mortal ailments. So that would be a hypothesis that has a continuous predictor variable. So dose would be our predictor there, and then basically the percent surviving, or the probability of survival, one or the other of those, could be the response variable. So in that case, I would use one of these blue columns, and that would be the dose, maybe in microliters. And then my response variable could be percent surviving at the end of 10 years. Percent surviving. Nope. Surviving after 10 years. It's kind of a long variable name. We're going to go with it for now. All right, so I'm going to copy some data over here so you don't have to watch me type, but these could be my doses. I have maybe 10 groups that I'm looking at here. And then my percent surviving in 10 different studies looking at this medication might be these values. And that's all I would want to do there. So I have a predictor variable, I have a response variable. Both are continuous numeric variables. So in that case, I would go on to do probably a linear regression of some sort. All right, my other example, I'm going to keep these two columns here because we're going to use them in the other example as well. I might have a more group-based hypothesis. So down here, if age influences the effectiveness of the immortality drug, then younger patients should experience greater immortality because their bodies are in better condition to start. So notice in both of these hypotheses, I use the if then because format, which is our gold standard for this class. All right, so in this case, I don't have numeric predictor variables. In this case, the actual group is going to be my predictor variable. So I might have age divided up into two age groups. I think we have a couple projects like that. So I could have young folks and old folks. Let's say this is our old folks column. So this would be now, instead of the percent surviving after 10 years, I could change this to the percent of old patients surviving beyond 10 years from their dose. Old patients. There we go. And in that case, I have my old patients. Now I might also have data for younger patients, and somewhere I would define what makes a patient old versus young. So this would be the full column heading, but in order to just see what we did here, I'm just going to replace this with old and this with young. And there we have it. So in this case, these are the only two columns that I'm going to need for my analysis, because in this case, the age group is actually my predictor variable, and then I have response values for each. You guys had a minimum target of 5 data points for each group. So this is more data than than the minimal requirements for sure. So don't be worried if you have fewer data points than that. You're fine. All right. That is how we want to format our data. So now, depending on which of those two versions most represents your data set, that's what you use to make your decision about the analysis. So if you're comparing, or if you're looking at a numeric predictor variable and a numeric response variable, like in the first example, then you're going to want to click on the how-to video for the linear regression, unless that's something you already know how to do. If your data looks like this, where you have 2 groups and your response values listed under each group, then you want to, you're going to be doing some kind of comparison of center. So either a means comparison or a median comparison, depending on the results of your normality test. All right, that's all I have here. So figure out the direction you're going to go next, and hopefully there will be a video to help you do that.